Greetings to all students. Now today in this video, I'm going to talk about what is benzene ring. Now before that, let's take a look at the learning outcome for this chapter. Kalau kita lihat, kita ada 3 subtopic. We have 6.1 introduction, 6.2 nomenclature, nomenclature is naming, and 6.3 is the chemical properties of benzene. So dalam video ini, Madam hanya akan cover 6.1 sahaja, iaitu pengenalan. So let's take a look. Okay, now for 6.1, it is only falls on C2, which is of course dia hanya keluar pada UPS sahajalah. Tapi usually because this is introduction, this is something you have to know. Of course mungkin dia akan dikaitkan juga masa PSPM nanti. Okay, now let's take a look at what is benzene. So Madam rasa awak semua memang tahu apa itu benzene ring. Kalau Madam tunjuk lukisan, mungkin awak tahu. But more about it, mungkin awak tak tahu. Okay, so as you can see here, beside name as benzene ataupun aromatic ring, dia juga dikenali sebagai arene. Okay, dia juga dikenali sebagai arene. So whenever you heard the word arene, or you know, it is actually referring to the benzene ring. Okay, so benzene ring ini dia adalah cyclic. Lepas tu dia adalah conjugated molecule, and then satu lagi dia adalah unsaturated molecule. Okay, so as you can see here, mentioned here, it is stabilized by pi electron delocalization. So I'm going to explain to you what is meant by pi electron delocalization. Okay, kalau dalam benzene, kalau alkene, it undergoes electrophilic addition, but for benzene ring, the type of reaction is electrophilic aromatic substitution. Okay, we name it as electrophilic aromatic substitution, ataupun you just can say electrophilic substitution. So mungkin awak macam terfikir jugalah, mungkin lah kan, kalau kita lukis benzene ring, it seems like it has 3 double bond. So kalau alkene, double bond undergoes electrophilic addition. So why benzene it undergoes electrophilic substitution? Okay, so kita akan belajar ini kemudian pada video ketiga nanti. Alright, so kita tinggalkan sebagai misteri. Now this is the structure. Okay, as you can see this thing. Okay, this is known as Kekule structure. Okay, this one is known as Kekule structure. So it was first proposed by August Kekule in 1865, and actually August Kekule ni lah yang bagi cadangan alternating double bond and single bond ini. Okay, tapi sebenarnya dia bukannya single bond, dia bukannya double bond. Okay, and again I will explain to you about that later. So as you can see, in your notes here, mentioned that each carbon atom in benzene is sp2 hybridized. Okay, and then dia akan ada satu one ion hybrid sp. I will explain again to you all this one later juga. So when it comes to resonance, masih ingat lagi resonance ke? Okay, resonance is where you tengok double bond dia selalu kan berubah-ubah. So kita lihat ini. So maybe some of you will start start drawing your benzene ring like this, where your double bond is at this side and alternate to this and alternate to this. But dia juga boleh dilukis seperti ini. Okay, so ini kita panggil sebagai resonance lah. Okay, dia sebagai resonance. And ada juga orang lukis seperti ini, bulat ni. So mari kita lihat apa dia kata. Now this drawing represent the 6 pi electron distributed over the 6 atoms of the ring. We have one keyword here, which is 6 pi electrons. So what is actually this 6 pi electron? Okay, mari kita lihat. Madam explain ya. Okay, now, like I mentioned before, all the carbon in benzene ring is sp2 hybridized. So, selalunya kita akan lukis dia seperti ini kan. Okay, kita akan lukis dia seperti ini. Kalau kita, kalau kita buka dia, if we open the structure, we are going to get something like this. Okay, and then I told you before that each of the carbon is having one hydrogen. So kalau kita lihat lah kan, yes indeed this is sp2. Sebab dia ada 1, 2, 3. So this carbon is sp2. sp2. Macam tu kan? Okay. So that's why we call it sp2. Cuma mari kita, Madam nak explain dengan lebih lanjut kenapa dia sp2. Okay. So if you remember carbon, kalau ingat carbon, kalau kita lukis, when it comes to hybridization, so we have 1, 2, 3, 4 valence electron. This one is at ground state, okay? Ground state. Madam ke sini. This is ground state. Okay, and then as you can see, this carbon, this carbon attached to three atoms, which is carbon, and hydrogen. Okay, so each of them, if you look at all the carbons, they're attached with 3 atoms, which means we need 3 singles electron. Okay, we need 3 singles electron. So we have to excite the electron since we only have 2 single electron there. Okay, so when we excite, therefore all the electrons will be single like this. Okay, excited. State. Now, this carbon only sp2, so we only need 3 single electron. 1, 2. So 1, 2, and 3, and left another one. If you still remember, we learned that before in first semester. So ada satu tertinggal kan? Okay, katakan yang satu ni, Madam lukis dia, represent dia warna merah lah. Okay, this one. Okay. So this is your sp2, and this one we name it as unhybridized p electron. Okay, p electron. So dia tidak dihybrid, right? Dia tidak dihybrid. So ini yang kalau lihat tadi dia ada kata it has wait, if I can move here, 6 pi electron. Okay, represent the 6 pi electron. So actually ini kan, dan kemudian kita ada 6 carbon. So Madam buat pi elektron tu di tengah-tengah sini. So each of them, carbon ini pun ada 1. This carbon also got 1. This carbon also got 1 pi electron, and pi electron. Okay, so sebenarnya the double bond that you see, dia bukannya double bond, tapi dia adalah pi electron. Okay, dia adalah pi electron. So August Kekulé get this idea, kemudian dia kata, okay, untuk lukisan, why not kita just buat seperti ini. Represent one line, and represent one line. Sebab itu, lukisan kita dilukis seperti ini. Okay, kalau kita lukis semula, dia akan jadi ni. Okay. One, two, three, four, five, six. Okay, dia akan jadi seperti ini. Ataupun macam Medan cakap tadi, boleh juga kita lukis dia seperti ini. Okay, dia dah macam ni pun boleh, tak ada masalah. Kemudian ada orang, Medan tak ingat siapa yang propose lukisan ini, bulat. So actually, this is what we said. The circle means the circle is representing the six apa ni? Six what we call this? 6 pi electron. Okay. So this is the explanation why it is sp2 and why it has 6 unhybridized electrons. So I hope this explanation can make you understand why benzene ring is having sp2 hybrid and 6 unhybridized p electron. So if I can conclude the structure of benzene, okay, as you can see here, benzene is having a molecular formula C6H6, and then kita boleh lukis dia dalam bentuk capsule structure seperti ini. Ini capsule structure. Okay, oops. Ini ciri-ciri dia adalah planar ya, planar rata sahaja. Dia tak ada yang unjuran ke hadapan atau unjuran ke belakang. It's a very planar molecule. And then it has a sigma bond. Tapi bila dia ada sigma bond, dia sp2 juga. And then at the same time, because of the 6 pi electron, kita ada 6 pi electron, so dia akan susun seperti ini, and actually they are very close to each other. Okay, so dia membentuk, bila dia berdekat tu, dia macam membentuk perjalanan, macam ni lah jalan raya. Okay, kalau awak boleh imagine lah kan, bowling pin tu semua duduk dekat-dekat. So bila dia berdekat-dekat, dia jadi macam, dia membentuk macam satu jalan raya lah, Madam panggil. But in this topic we said it is a delocalized pi system. So 6 elektron tu dia jalan dekat sini lah. Dia jalan. Okay, not here only. Kadang-kadang dia di bawah ni lah. Okay. So elektron itu sentiasa bergerak, and that is why we said delocalized pi. And then selalunya kita akan tambah pi elektron. Okay, pi elektron itu sentiasa bergerak ke sana sini without stopping. And this is a simplified drawing. Ini yang kita selalu lukis dia sebagai benzene ring. Okay. Okay, so what is the criteria for becoming benzene ring? Okay, dia mesti cyclic, dia mesti planar, dia mesti completely conjugate. Okay, kalau completely conjugate tu inilah. Okay, this is completely conjugate. Maksudnya dia punya pi cloud itu, kalau masih ingat dia punya bukan, dia punya p orbital itu dia dekat-dekat with each other, dan itu yang akan jadi conjugated. Okay, kalau Madam sempat jumpa awak nanti masa face to face, Madam akan explain macam mana kejadiannya. Okay, so and then dia mesti obey Huckel's rules. So Huckel's rules tu apa? So Huckel's rules ini dia adalah sejenis pengiraan untuk menentukan bilangan elektron dia. So ini dia punya formula. Okay, this is the formula. Tapi kalau dulu benda ni awak kira-kira, but now tak perlu kira dah. Okay, so you just need to know 4n plus 2 pi electron. You only need to know the formula tanpa perlu mengira. Okay, so selalunya dia punya pengiraan tu ada 2, 6, 10, 14 pi elektron. So tak semestinya 6. Okay, tak semestinya 6. Tapi kalau dia sejenis cyclic, planar, completely conjugate, dan dia ada 2 pi elektron pun, kita boleh panggil dia sebagai benzene ring. Tapi like I said, this is not in your syllabus anymore. Only awak hanya perlu tahu macam tu sahaja. Okay. So this is it. And itu sahaja pengenalan untuk benzene ring. So can proceed to the in the next video. I'm going to talk about how to give name to the benzene ring. Thank you, everyone.